Hello. Okay, should see you should hear me and you should see the screen, the desktop by now. Um, okay. Um, okay. Is the desktop visible? Can you hear me? Does everything seem okay?
Yes.
Okay, great. Thank you. Okay. So, um, today we're going to talk about there's no new reading assignment. We're right now we're talking about the reading assignment from way back last week. Okay. So today we're going to talk about nested for loops. Okay, so we're going to be talking this week. We're going to talk about nested for loops. Um, as we talk about nested for loops, we'll mention methods again. There's a reading assignment from last Thursday on, this chapter on methods. It's a review actually because we've talked about methods before, but we haven't said a whole lot about them lately. So we'll be saying a little bit about methods as we talk about nested for loops. So you might want to read that section to remind yourself about methods. These were just review sections about loops. So the real topic to talk about is nested for loops. Okay, so that's the topic we're going to talk about for this whole week. Okay, and then these two sections review loops, and then this section reviews methods, which we're going to make a little bit of use of. And then after we finish nested for loops, we'll talk a lot more about methods for a while. Okay, and here's some more coding bat problems I think it'd be good to work on. These these two are logic ones, and these two are similar to what these three are similar to what we were doing last week when we talked about string walking. Okay, so these are three coding bat problems that are string walking type problems. They involve strings and a single loop. Okay, so I mean, and if you go to there, these string two problems, I gave you three of them, but if you actually look, there's a lot of these problems. These are all various kinds of problems that involve strings and loops. Okay, so I picked three of them that I think are that you should try. I picked these three, and any more you want to do is good practice, but you should definitely give these three a try here. And these two are just on logic. These two are more practice with ands and ors. So that this is practice with ands and or a little bit more harder. So instead of logic 2. So they're a little bit, there is a section on logic 1, but they're really easy. So this is two slightly more, what they consider medium problems. If you go back here, there are logic 1 problems, real simple problems involving if statements. And the logic 2 problems are just a little bit what they call medium problems. Okay, so I picked two of the medium logic problems and three of the problems involving strings and a loop, okay, the string walking problems. This is the best kind of way you could practice programming, is to do these kinds of problems. Reading the book is reading is not going to, it's like math. Reading helps, but you don't learn from the reading. You learn from actually doing, and then going back and rereading. As you try to do these and you come up with questions, you go back and reread. But the your reading really should be driven by trying to solve problems. The best strategy for learning is try to solve problems. And as you solve problems, you have to like look things up and remind yourself how things work. Just reading by itself doesn't sink in for anybody very well with math and programming. But if you're solving problems and you're saying, I don't remember how to do that, or you go back and see if there's something in one of these sections that helps you solve the problem. Having a goal of solving a problem makes it a lot better to then go back and reread. Okay, so work on these problems. These are the best way to check that you're learning and to move your learning forward by solving these, practice with these things. Do one a day. Do one of these a day. That's 5 days worth of problems right there. Okay, so that's very, very, very good practice. And if you have questions about them, You can always say, if you get stuck on one of these, or if you're not really sure how to get started, you can always send me an email, ask for a meeting, a Zoom meeting if you want. But these are a great way to practice. And as I mentioned before, uh, after you get to be a sophomore, if you want to apply for internships and things like that, people use websites just like CodingBat for doing job interviews. When people interview you for jobs or interview for internships, they don't. I don't know if anyone uses CodingBat, because CodingBat problems are considered probably a little bit too easy because they're for a freshman programming class. But they use sites like CodingBat. CodingBat's kind of a warm-up for the more sophisticated sites that are used for interviews and jobs, and also programmers use them for just learning. Uh, Programmers, even professional ones, they use these problem sites as a way to just keep themselves up to date and learn new things. So CodingBat's a great place to start getting used to this way of learning. Okay, so please look at those problems. All right, so what we want to do is start talking about nested for loops. Okay, now let me start up Dr. Java to just show you a quick thing of what I mean by nested for loops. Okay, so for us, if we go back here, let's see, I think we have this thing that outlines what while loops and for loops, like there's our basic for loop idea. Remember, a basic for loop was you had something that initialized the variable, something that tested the variable, and something that incremented the variable, and then you did something inside here. Okay, and the idea is that you would start here to create the variable, test it test it. If it passes if the test is true, you do this, and then you go do the increment. Then you do the test again, and then if the test is true, you do this thing again. Then you do the increment. And the big difference between this and a while loop was that the increment is what changes the test. In a for loop, you tend to have the increment change the test. Whereas in a while loop, remember, this do something better change the test. The basic while loop, the idea in a while loop was that the do something had to change the test. If it didn't change the test, you'd loop forever. So that's a little bit harder to think about. This thing better somehow change this thing. Otherwise, this thing's a infinite loop. Okay, a for loop makes it a little bit easier to read. You have this. You say this is the variable I want to use. This is the test on the variable. This is how the variable increment. So that's all in one place. And then this thing will just do something, but it's this part that's going to change the test. Okay, so that makes for loops a little bit easier to use than while loops, because the test and the increment are up here, and this thing just does what you need done for each iterate, and it doesn't have to affect the test. But with a while loop, you have to have this guy also modify the test. Okay, now this is our basic for loop. Okay, so there's our basic for loop. Now what I want to do is the idea that take a for loop and put a for loop inside of a for loop. So the do something is now another for loop. So the do something, we call this the outer loop. And we call this one the inner loop. Oops. Okay. Then the do something is something that's done. Notice that for the outer loop, the do something is the whole inner loop. The inner loop is the do something for the outer loop. Then the inner loop has its own do something. Okay, and this will create one variable for the outer loop. This will create another variable for the inner loop. This will be a test of the outer loop. This will be a test for the inner loop. This will increment the variable for the outer loop, and this will increment the variable for the inner loop. Okay, so for example, if I make this one real specific, so I'll have an int I going from 1 here. and I'll make this one an int j, say start it at 1. I use a different letter for each of these. This loop will be controlled by I, this loop will be controlled by j. Maybe this one I'll have I less than or equal to 4. And maybe this one will be j is less than or equal to 5. And then this one will increment I, and this one will increment j. Okay. Now, the key here is now when I do something, I'm using I and j to affect what I do. Okay, the I will measure something that's being counted by the outer loop. J will measure something that's being counted by the inner loop. And when I do something in here, I make use of the I and j. Okay, and this is going to be, and notice that since there's, the way it works is you pick I starting at 1, then you do 5 loops of j. So with I1, you do 5 loops of j. So you do 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Then you'll change I to 2. Then you'll go back here with I being 2, you'll do 5 more loops of j. And you'll be doing 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. Okay? This whole thing will be done 20 times.
Is it
Say again?
Is it possible to use if statements to do something different for every value of the integer?
Oh yeah, yeah. As we go along, we'll do. Yeah, we'll definitely inside here. We might say, well, if I has a certain value, do one thing. If I and j are equal, do something else. So inside here, there could be all kinds of logic. The idea is you're going to use I and j, and yeah, you can have all kinds of logic that says, well, what if I is less than j? What if I is equal to j? What if I is greater than j? Yeah, and so you could definitely have the do something will be dependent on the values of I and j. Okay, whatever do something does, it'll be done 20 times because for each one of the 4 values of I, you do j 5 times. If I make this, say, a 6 here and a 10 here, then it's going to be altogether 60 times because I will go from 1 to 6. There'll be 6 different values of I. For each value of I, there'll be 10 values of j. So that's 6 values of I, and each one gets 10 values of j. So there's 60. So do something's done 60 times. You're probably not going to do the exact same thing 60 times. Now, if you completely ignore the I and the j, you'd just be doing the exact same thing 60 times. The idea is to make use of I and j with if statements or logic, but to not do the exact same thing 60 times, but to do something 60 times making use of I and j. Okay? All right, so that's the idea. We'll see that this quite often ends up having to do with the rows and columns of a table. It's going to be real common for this to involve the rows and columns of a table. I mean, well, we'll see. I can't think of a quick example, but if you look in the textbook for the reading assignment about nested for loops, okay, you look at notice that their picture there is what I was showing here. Okay, so here's the example I gave, and here's their example. But their example, I just used letters like I and J. They started off by saying row and column because it's a little bit misleading over here because they're implying that you're always dealing with rows and columns. That's not true. When you have nested for loops, you're very often dealing with rows and columns in a table, but not always. Okay, there's no reason to think you always have a row and a column in a table, but that's how they kind of thought about this here. The outer loop and the inner loop. The outer loop is picking a row. So here they're thinking if there's 3 rows. And then the inner loop is picking a column in a row, and there's 5 columns. So this is true. This is going over the rows and columns of a table. It turns out that nested for loops don't have to be about rows and tables, but they often are about rows and tables. So here I just try to use more generic letters, like I goes from 1 to 6 and J goes from 1 to 10. Okay, that's not saying that this is a row, but many times it is a row. And that's not saying that this is a column, but it might be a column. Here they just went right away. They just said rows and columns. Okay, all right. So now let's look at some actual code examples of using something like this. I've got a folder where I've got some examples. Okay. Now, what I want to do is I want to take this example and put it on the Java visualizer. So I'm actually going to copy it. Instead of running it in Dr. Java, I'm going to copy it to the Java visualizer. Okay. Okay. Now, this one's not going to be a table. Okay. But this one's going to help us see a little bit about what a nested for loops do. So this one is not a table. Okay, so I is going from 1 to 6, and for each I, J goes from 1 to 4. And then what it does is the do something just prints out a little message. And it just says, hello from I equals blah, J equals blah. So it just gives us a little message. And it's actually going to show us how the for loop is acting without generating a table. So let me run it. And I'm just going to go, I'm not going to run it. I'll just go to look at the output. So there's the end. Now go down here and look at how the output looks like. See, this is how it's saying that, see, first you pick I equals 1. Let's see if I can get all this to show up in the screen. What would I do? Let me see if I can get this to show up. Okay, so here's the output, here's the code. Now we said that you pick an I, start with 1, then you go in here, and then J goes from 1 to 4. See, that's it. This is. So you here, see how these first 4 rows all have I equal 1? Because those first 4 rows here, that's this inner loop going 4 times around with I being 1. Okay? Now, after you go 4 times around this thing with I equals 1, you're done with this one. So you go back up here and you go to I equals 2. Then here's I equals 2. And then you go through here 4 times with I equals 2. So I equals 2 and J is 1, 2, 3, 4. Okay, so this shows us how we should think about it. You pick a value for the outer loop and then you run through the inner loop. When you're running through the inner loop, the outer loop variable just is held fixed. Now, what you have to make sure is that some people make the mistake of thinking that when you get down to here, I and J are moving sort of in parallel. So I is 1, J is 1. I is 2, J is 2. I is 3, J is 3. I is 4, J is 4. And that's really wrong. It doesn't work that way at all. It does not increment I and J in parallel. The outer loop picks an I, and then the inner loop runs from beginning to end. So you see that here. You pick I as 1, and then while I is 1, you run through the whole inner loop. So you'll have here I is 1 and J is 1, then I is 1 and J is 2, then I is 1, J is 3, I is 1, J is 4. That runs through this loop, and now you get I equals 2. Then I equals, so now you're down here. So you have to read these real carefully. See, you can't just somehow think, oh, I've got 2 loops. I is going from 1 to 6, J is going from 1 to 4, so I go 1, 1, 1, 1, 1, 2, 2, 2, 3, 3. Now, in a way, you have to realize that doesn't make sense, because if this was going 1, 1, 2, 2, 3, 3, 4, 4, what happens when I gets to 5, but J ended at 4? See, it wouldn't even make sense. There'd be more values of I than there are of J. So, but I've seen a lot of people make this mistake of somehow thinking that these are incrementing together. They're not incrementing together. The I increments by itself, and then the J's run through their values. Then after the J's have run through all their values, go back and make I again, then run the J's through their values again. Now let's actually watch the loop execute. So what I'll do is go back to the beginning, and now just step through it and watch how it's going to do this. Okay, so we're in this line. Right now, remember, for loop, you start here in this part. So the next thing I'm going to do is create I. See, but I'm still on line 5 because now I've created I, and now I'm going to test I. So I'm still on line 5, and now I'm going to test I and find out it's true. 1 is less than 6. So when I click forward, then I'm going to go into line 7. Okay, so now I'm at line. See, I just left this thing. It was true. Now I'm here. Now here I'm right there. Now I'm going to create J. And now I've moved to here. Now I'm testing whether J is less than 4. That's true, so I'm going to move to line 9. Okay, now I'm in line 9. I is 1, J is 1, and I print out my message. Okay, now I'm back here. I'm at this part. See, remember there's 3 pieces here. I went from this piece to this piece down to here. Now I'm back here. Now I'm about to change J to 2. Okay, I just changed J to 2, so now I'm back to this piece. I have to test it. J less than 4. That's going to be true, so then I'm going to go back down here. Now I is 1, J is 2. Print out I1, J2. Back to here. Increment J. Back to here. Test it. Go down here. Print out I is 1, J is 3. I'm back to here now. Increment it. Test it. Back down here. I equals 1, J equals 4. Okay, now you think we're done, but remember, the loop's not quite done yet because the loop has to find out that it's done. It's done 1, 2, 3, 4, J equals 1, J equals 2, J equals 3, J equals 4, but the loop doesn't know that it's done yet. What do I mean by that? Okay, I'm really right here now. So I need to increment J to 5. Then I go back here and say, oh, is 5 less than 4? No, that's false. That's what really ends the loop. Where do I go? I'm about to click forward. This is false. Where am I going to go? There's a question, like, where will I go now?
You go back to the outer loop.
Yeah, so where do I go? What line specifically do I go to?
5.
Line 5. And where will I be in line 5? Okay, click forward, go back to line 5. Where am I?
You go to check the condition.
No, not where. When you go back to the 4, where do you always go into it?
Increment.
Increment, yes. See, I have to increment the I now. So I go, remember our picture. Remember the picture of a for loop. We're going to use it all the time. Come into initialize, do the test, do this, go to increment, test, do this. Remember the loop is test, do, increment, test, do, increment, test, do, increment. So we go around and around like this, okay? So now we're over here. We finished this for loop. We came over to the incrementer. We're going to increment I. Oh, we're going to increment I. Now, notice here one thing. Let me go back a couple steps. We were right here. J was 5. That failed, okay? So we went from 7 to 5. But look what happened. J disappears. What is it that makes J disappear? It's a little bit trickier question. Why did J disappear when I went from 7 to 5?
Because there's no longer an integer J on 5.
Yeah, why not? Well, yeah, how do you explain to somebody? What, like, it's right there. I can see it. What's the
Because it's
job?
not up to that step yet.
Well, what's the rule about this J?
It's not initialized.
It's only initialized between lines 7 and 10. See, it only lives in that for loop. See, so where does I live?
Line 5.
Line 5 to
5 through 10
5 through
or 5 through
actually
11.
11. 5 through 11. No, yeah, 5 through 11. I lives from 5 to 11. J lives from 7 to 10. So since we've jumped from 7 back to 5, J disappears on us. Okay.
I have
So-
a question.
Yeah.
Okay, so what if before the for loop, say I equals 7, right? And then after the whole entire for loop, it changes back to 1. Would it then go back into the for loop or no?
Well, no, it won't. No.
Okay.
Well, first of all, since you can't, when this J gets to line 10, it disappears, so you can't change it afterwards. And here's okay. The when the for loop ends, the J just disappears. It doesn't go back to being 1, if that's what you meant. I mean, yeah, when you leave this for loop, J disappears.
What if you declare I as an integer before the for loop?
That's completely different. Yeah, that's a different issue. So for example, I could do the following. Now that J lives from line 5 to the end of the program. So when I leave this for loop, J doesn't disappear on me because I declared it on its own. J lives on its own. It's used in the for loop, but it doesn't belong to the for loop. The I belongs to the for loop. It only exists between 6 and 12 now. But J is not, it doesn't belong to the for loop, this for loop. So then when that, let's see, we can just do it real quick. I'm going to step through a bunch of times. Okay. Okay, I'm inside the for loop. Okay, J is 4, J is 5. Now, okay, I'm here. J is 5. I'm at this step here, and I'm about to fail this test and go back up to line 6. And when I do it now, what did I do? I hit the wrong button. Okay, there's J4. I printed out J. I equals 1, J equals 4. So I just printed this out. Increment J, 2, 5. Test this. It's going to fail. When it fails, I go back up to line 6, but J doesn't go away. See, I'm in line 6, and J is 5. Okay? Because the J didn't disappear when I went back up to here. Now I'm over here. I is going to go from 1 to 2. Okay. Now what's interesting is what happens when I enter back into the loop. Oh, no. So I just incremented I to 2. So now I'm going to do this. Okay. This is going to pass. So I'm going to go down to the loop. I'm going to go to line 8. What happened? J disappeared. This might be a weird bug in the visualizer. Notice that, what? Look at that. J disappeared. Okay, where was I? Okay, back up a little bit. Okay, here I'm about to print. I just printed I equals 1, J equals 4. So I just did line 10. That means I'm right here. Increment J. J's 5. Now I'm right here. Test J. Okay, 5 less than 4 is going to be false. So I'm going to go back up to line 6. Okay, I'm in line 6. Okay, notice that, J is 5. Okay, now I'm in line 6 here. I'm incrementing I. So I is going to go to 2. Okay, then I'm here. Check I again. I is less than 6. That's going to be true. So I'm going to go back into here. And for some bizarre reason, J disappeared on me. I think that's a bug in the visualizer. Okay, it made J disappear. Now I'm down here. What should have happened is J should be there with a 5 in it, but this would change it back to a 1. You should have seen J sit there and go from 5 to 1. It should not have disappeared. I'm not sure why it disappeared. Maybe because I didn't give it a value here. I think it's a bug in the visualizer. Let me try something else. Let me make it equal to 0 here, just for the heck of it. See if that changes how it behaves. Unfortunately, the visualizer sometimes there's bugs in the tools you're working with. Okay, so let's go through. Oh, I'm sorry, I went too many steps. Okay, now I'm about to print I equals 1, J equals 4. Okay, so I print I equals 1, J equals 4. I go back up here and I increment J. J is 5. Okay, then I go here to test if it's true or not. So now I'm testing whether it's true. It's going to be false, so I'm going to go to line 6. Okay, I'm at line 6. Notice that J's hanging around. Okay, I'm at line 6 here. Okay, increment. Now increment the I. I is 2. Now I have to test the I. So I is, now this is going to be true, so I should go back to line 8. Ah, and J didn't disappear this time. So it's weird. It's got to do with whether I initialized J or not. When I didn't initialize J, the visualizer got a little bit mixed up, I think, because the J was still there, but it disappeared it because it wasn't initialized. Now watch what happens. I'm at line 8. J is 5. Why do I not get screwed up? What's the net? Where am I on line 8? Okay, I tested I is true, I is 2, 2 is less than 6, so this is true. So I go into the loop. I'm at line 8. Where am I in line 8?
It's going to make J equal to 1.
Yeah, it resets it. See, that resets it back to 1. Okay, because we went to the, we always come in at the initialized part. You always enter a for loop. You enter it at the initialized part. So I'm entering this for loop at J equals 1. It's the same J as it was before. Now, before it would create a new J for us when it got to line 8. Now it's the same old J, but it gets reset to 1. And if I had this without the equals 0, the visualizer got a little bit mixed up, and the visualizer showed the J disappearing on us, which it doesn't do. It does not disappear like it did in the case where you declared J in the for loop. When you declare the J in the for loop, it disappears when you leave the for loop. But when I declare J up here, it doesn't ever disappear, but the visualizer was getting messed up. Okay, so if I did that thing of making this just int J without setting it equal to 0, the visualizer got a little mixed up and at some point made J disappear on us. Okay, so now sometimes you want your code like this, with the variable outside of the loop. Not very often. That's usually, almost always, not the right thing to do. The loop variable should be inside the loop. Okay, the right way to do it is like that. This is not usually the right thing to do. Okay, so now if I wanted to, I could even do this. See, I could declare both of them outside of the loop. Not a good idea. Okay, you'll see a lot of programmers actually do it this way. There's a small reason why you would do it this way, and you will see this code written this way a lot because when the C language was invented, it required you to do it this way. You declared all your loop variables before the loops. But that was many years ago. Not even the C language works that way anymore. But there's a lot of programmers who still have the habit of declaring their loop variables before the loops because of old-fashioned C programming. And you'll see it in textbooks and you'll see it used by lots of people, but it's a bad habit that comes from the 60s and 70s because of an old version of C. And some people think it's still a rule, but it hasn't been a rule for 30 years. I meet programmers who still think they're supposed to declare their loop variables before the loop. Okay, you only do that in special cases when you need the variable outside of the loop, which isn't very often. It's not very often that you need these variables outside of the loop. So the preferred way nowadays is the loop variable should be inside the loop like that. Okay, now that means that when this loop ends and you go back up here, J disappears for a brief moment. Then when you enter line 8, you create a new J equal to 1. And that's what we see now over here. Okay, I'll step through it real fast. J 1, 2, 3, 4. Okay, there's J4. Now J's 5. I just made J5. I'm going to test this guy. This is going to be false. So I'm going to leave the loop and J disappears. See, it was false. I left the loop and J disappears. That's the right way to do it. Okay. Now I goes up to 2. See, I just made I 2. Test I again. It's okay. 2 is less than 6. That's going to take me down to line 8. And like before, I'm at this part of line 8, which creates a new J. Instead of resetting the old J, now it creates a new J. Now notice the difference. If you did it this way, you'd be resetting the old J to 1. If you didn't have this int here, if you had it up here, at this point you'd be resetting the old J back to 1. Instead here, we're creating a new J. These subtle differences make a big difference. You can get weird bugs in programs if you get this goofed up. If you're not really paying attention carefully to how you use your loop variables, you can get weird errors by kind of like declaring a loop variable in the wrong place and then not realizing what's happening. Okay, so if you do it the right way, when you enter the loop, this creates a new J, and we'll see it here. So now we create a new J at 1. Now we loop through. I is 2, J is 3, 4. Now there's J5. I've finished the second loop, the second time around. I finished my second time around here. I'm testing J again. J is 5. 5 is not less than 4. This is going to fail. That's going to take me back up to line 6. And J is going to disappear on me again. See, I'm back to line 6. I'm right there. About to change I to 3. Now I'm there. Check the I. That's okay. I'm back at 8, and I'm back here now. Now I create a third J. Okay, I'm really on my third J, starting at 1. Okay, so this lets us watch the for loop. Okay, and keep this picture in mind. In, test, do, increment, test, do, increment. Yeah, the loop is right there in that order. Every time as soon as you finish the do, you go to the increment, then the test again. It's really crucial to see that order when, notice that you read this kind of funny, from here to here, down to here, over to here, back to here. Sometimes you read from left to right, sometimes you read from right to left, okay? You read this part from left to right. You do the initialization one time, and then after initialization, you move right to this guy. But then you don't go to this guy. From here, you go down here. Then from here, you go up to here, and then you move left to here. Okay, so practice, concentrate when you read these on reading them in the right order, because as we do trickier problems, you solve tricky problems by keeping track of what order these things are happening in. Okay, so there's a real basic a nested for loop that just lets us see what it's doing. Notice it's not a table. There isn't a notion here of rows and columns. Okay, so let's switch it now to being a table. Let's see how it's not too hard to switch this into something that's a table. Okay, so I'm going to do a real minor little change here. I'm going to print a star. That's all. Okay, I'm going to print a star. Now look at the output. Go to the end. Oops, I'm sorry. I'm sorry, I need to make two other changes. Well, actually, let me let me do it in a better way. Let me show you a better way to think about this. Let's actually think about how we might print a small table. Okay, so I'm going to print a kind of a simplistic table. Okay, there's a little table. It's got 1, 2, 3, 4, 5, 6 columns and 4 rows. Okay, so it's a real simple little table. It's right now it's a table of stars. It's got 1, 2, 3, 4 rows, and each row has in it 1, 2, 3, 4, 5, 6. Okay. All right. So now let me think about how this could be done with for loops. So first of all, I'm doing this 4 times. Okay. So an obvious thing to do is get rid of 3 of these and wrap it in a for loop. So for int I equals 1, I less than or equal to 4, I plus plus, okay. Now I've got my table. I'm typing a little bit less code. Now I've got my table. There's my same table, okay, with a little bit less code, okay. Now let me do another thing to change this. Notice that this is star, 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 star. Here's a funny way to get 6 stars in a row. This might seem kind of stupid at first, but here's a funny way to get 6 stars in a row. 1, 2, 3, 4, 5, 6 stars. But then I want that to be an end. I want to end the line. So let me print a blank line. Okay. There's a row of 6 stars. Okay. And if you visualize this, it still gives me the same table. But now you see that there's really a second loop involved. See, I did it kind of a dumb way, but the point of the dumb way was to see that there's really a second loop here. Okay. So see, the 6 stars are an inner loop. So what I'm going to do is get rid of 5 of them and make it a loop here. For int j equals 1, j less than or equal to 6. I want 6 stars, j plus plus. And what's interesting is notice that the print line was not part of the loop. See, it wasn't the thing. It wasn't one of the things being repeated. There was 6 lines that printed stars. But then after the 6 stars, there was this one line that would be something that maybe go back to the beginning of the next line. So my for loop now is print 6 stars and then end the line. So now if I go visualize this, what did I do wrong? Oh, I did the same thing here. I got a star here instead of a print. Okay. See, there's my same table. Now, what's nice about this? Can we think? Tell me something kind of nice about this versus what we did the last before, all the code that came before.
You can change easier what's being printed out.
Yeah, so what if I want 27 rows?
And you just change j is less than or equal to 6, change that to 27.
Ah, that doesn't give me 27 rows.
You change I.
Change I to be There's 27 rows. What does that give me?
That's columns.
Columns. So that changes what? Now it would be what? How many rows?
That would be how many stars?
How many rows? Yeah. So this is 4 is how many rows, and 27 is how many? What's the end of it? 27 is how many?
Columns.
Or what's a better way to put it?
Lines.
Stars
Oh, I don't know.
in a row. How many rows? How many stars in a row? Which is the same thing as the column. See, there's a lot of ways of saying the same thing. And we want to get used to these different ways of saying it. 4 is how many rows. This is how many stars are in a row, which is the same thing as how many columns there are. Okay, there's 4 rows of 27 stars. Notice how easy it is to change it. Here's going to be 8 rows of 3 stars. 8 rows of 3 stars. Okay, notice that I'm doing tables. And if you compare that to them, see, now I'm doing the exact same pattern that they did. See how that print line is outside of this loop here? And see how they're printing a star here? They're printing 3 rows of 5 stars per row. So this was 3 rows, 5 columns of star. So if I want, I can go back here and say, oh, this is row 1, row less than 8, change the row number. And I might do that just to make it easier to read, because now I'm really thinking rows and columns. And then this is from column 1 up to column 8, increment the column. This prints out 1 row, and this ends the row with a new line. Okay. Let's play around with this a little bit. Let's go back to, say, 4 rows of 5. What happens if I get rid of this?
You have 20 stars in one row.
Yeah. So how many rows are there now?
1,
1 row. And how long is that row?
20 stars.
20 stars. Notice it's not a table anymore. Yeah. Even though I use row and column, I have to be very careful. That's one thing I kind of didn't like about the way they wrote this. They wrote this in kind of a misleading way. That you have to be very careful when you read this. These are only rows and columns because they wrote this exactly a unique way. If I get rid of that line, they're not even rows and columns anymore. It's still nested loops. So see so let's watch it, visualize it. See, it's 1 row of 20 stars. You can count them. Now go back and why is that? What happened? I is 1. Okay. When I is 1, you do this 6 times. So 5 times. So you print 5 stars. Okay. Well, actually, let's go ahead and watch it. Just, Okay. So there's our 5 stars. Okay. We finished 1 row, so to speak. Now we're going to go row 2. What happens when I go back into this loop here? What happened to my row 2?
You print a star
But where's the star printed?
right after the 5 stars.
Yeah, it's right. It's either, see, this guy's gone. There's nothing that ever moves me to another row. This is the thing that actually moved me to another row. It's not there. So even if I want to call these rows and columns, they're no longer rows and columns. There's nothing that moved me to the next row. So I'm just stuck. I'm still printing on the same line. And it just keeps on going. See, I'm printing on that same line. As I keep iterating, it keeps printing on that same line. Okay, gotta be real careful with these. Okay, now let me do something else. What do I have now?
You have 20 columns of 1 star.
No, 20. You said 20 columns.
Oh, 20 rows.
20 rows of 1 star. Because now every time I print a star, it's on its own line. So I've now gotten 20 rows. Now go back and visualize it. Now notice it's not a table anymore. See, there's 20 rows with 1 star each. Again, I think they kind of didn't do a very good job explaining this. They got to be real careful here. It's only rows and columns if you do it very carefully. Print here, print line here. Otherwise, it's just nested for loops that could be doing almost anything. Okay, so here, we've got nested for loops. We're using row and column, but well, they're not rows and columns. One last little trick. Now what do I have?
You have 40 rows?
No.
No, you'll have
Yeah.
20 rows, each separated by a space.
Yes. This guy will now separate 5 vertical stars from the next 5 vertical stars with a blank line. So this will print 5 vertical stars, and then this will put a blank line between them. And then the for loop will say, do another 5 vertical stars with a blank line between them. So how many columns do I have?
20.
Columns?
10.
No. Everything
Still
is
just
on.
one.
Pardon me?
Still just one.
Just one column. How many rows are there actually in this thing? How many actual rows of output does this produce?
24.
Yes. Because what?
Well, you'd add 4 because you have a space every 5.
Yeah. So there's 20 rows with a star in them, and 4 rows with it are blank line, separating each 5. There's 5 stars blank line, 5 stars blank line, 5 stars blank line. Okay. So now notice it's important for us to start reading the code and knowing what it does without having to necessarily run it. So like, okay, here's running it. All right. There's 5 stars blank line. 5 stars blank line, 5 stars blank line, 5 stars blank line. Okay, all right. So notice it's not a table unless I do it the really careful way. It's a table if these are all on the same line, and this guy then breaks it into a separate, starts a new line. Now it's a table. Okay, be very, very careful. Okay. But now I have a lot of control over the table. I can say I want 10 rows of 15 columns. Okay, there's a nice little nice size table. There's 10 rows of 15 columns. Okay. All right. Now here's a tricky one. I'm actually going to, now I'm going to do something, I'm actually going to do something that we're going to start playing around with. I'm going to use the outer loop variable to control the inner loop. Notice I'm going to put the word row right there. This one's tricky. What do I end up doing? Okay, I pick a row between 1 and 10. Then in that row, what do I do?
You go through it once, pretty much, right?
Pardon me?
You go through it once.
What do you mean once? What? Okay, like suppose row is 7. Suppose I've gotten up to 7. What does
Okay.
line 7 do if row is 7?
Oh, it prints out 7 times,
Yeah. Now, what does it do on line 8?
8 times,
What does it do on line 3?
3.
Okay, so what does the output look like?
Well, it's kind of counterproductive because you could have just said since some out print within the first for loop.
No, no. So it does stop. Go for what does the output look like?
It
Row
just
one.
grows every time, right?
I mean,
It grows every time.
yeah. So first row has how many stars?
1,
Second row
1,
has
2,
2.
third row. So what does it look like?
a triangle.
Triangle. A right
Triangle,
triangle.
yeah. See? I'll put a little triangle. There. Okay. Standard little programming problem. Standard little trick. Okay. It prints out. Notice it's half a table. This is essentially half. This is called the lower triangle of a table. This is actually not an unusual thing to want to do. That's the lower half triangle of a table. What's a little bit harder is to draw the upper half triangle of that table. That takes more work, but we're going to do it. It's important enough that we're going to do it. See, this edge here is called the diagonal of the table. We have names for all this. This edge here is the diagonal of the table. Right now, we've drawn the lower half triangle of the table. We'd also like to be able to draw the upper half triangle of that table, because those are important ideas. They come up regularly in programming. So we started with a table, and we have things like the diagonal, the lower triangle, the upper triangle. Okay. So notice that a little trick was make the row, the length of a row depended on what row I was in. The number of columns in a row depended on what row I was in. Okay? Okay. What's going to happen now? Now think about it. Think about it step by step. I start at row 1. When I start at row 1, what happens in that row? What happens when I start at row 1? What happens here? One through what?
Oh, I see. Okay. So it'll print out 9 times, right?
Yeah. Then on row 2, the next one will do 1 through
8.
8,
Then row 3 will do 1 through.
7,
Okay, what am I printing?
a triangle, but
Yeah, but it's kind of what compared to the other one?
inverse.
Yeah, it's like flipped over. Okay, watch. There's the other triangle. See, it's been flipped over from what it was before. Okay, before it was starting out short and growing longer. Now it's starting out long and growing shorter. So I've got the opposite triangle. Okay. Right? Notice I'm playing games. What I'm doing is I'm playing games with using the outer loop variable to control the inner loop. This is where things get hard. This is what makes nested for loops a tricky subject. You start saying that the outer loop variable can now start changing the inner loop. Okay, let me do another one. What am I going to get now?
Do you still make a triangle?
Yeah, it's going to be another triangle. How does it start? When row is 1, what do I get for the first row?
You get 1 star.
You get 10 stars.
10 stars, yeah, because when row is 1, I start at 1 and go up to 10. What do I get in the second row? When row is 2, I do,
You get 9 stars.
because I do what?
Because you're starting off at 2, not
2.
1.
Yeah, I go from 2 to 10 and I get 9 stars. Then when row is 3, I get what?
7.
7 stars because I go from 3 to 10. So its triangle now starts out big and gets smaller as it goes down. So this is another version of the same thing that we saw a minute ago. Now it starts out big and grows small, but I did it a different way. I wrote the code a little bit differently, but got the same triangle. Started out big and then got smaller. I did that a couple different ways. I could either start here with row, or the other way I did it was to do see, 2 different ways of starting long and getting smaller. I did it 2 ways. Here, I can write them both out. Here's a little trick. Not used to this. Okay, now what I'm gonna do is choose either this one or this one. This one goes from column starts at row and goes up to 10, versus this one, column starts at 1 and goes up to 10 minus row. Both of those will give me, doesn't matter which one I use, either one will give me that triangle. See, notice it started big. Now I'll switch to the other one. Okay, now I'm using that one. This line's being ignored, but I'm going to get the same triangle. Okay, kind of tricky. So I've got 2 ways of getting that triangle. I could start the column counter at the number row and go up to 10, or I could start the column counter at 1 and go up to 10 minus row. And I get the same thing. A row of 10, then a row of 9, then a row of 8, then a row of 7, then a row of 6. Okay, all right. So notice I'm playing a game now where I'm letting the outer loop counter affect the inner loop counter. Okay, and I can affect it by where it starts, or I can affect it by where it ends. Okay, and I can do a lot of funny things with this way. A lot of programming tricks have to do with nested for loops, where the outer loop counter affects the inner loop counter in some way. Okay, all right. So I get what it is they let me do a table, but only do, here's, yeah, they let me look at parts of a table. They would let me go through a table, but only do parts of it. For example, let's do another one. No, let's see, let me think. No, yeah, we've pretty much done. Those are all the. Yeah, we got a bunch of different triangles. By you can take the key idea is you can take this outer loop counter and put it either in here or in here. You could have it affect where you start, or you could have it affect where you end. And depending on how you affect the start or the end, you can get these different kind of triangles. And we'll keep playing with these and see different strategies for different. But the idea is that let this guy either affect how this guy starts or how this guy ends. Okay. Now let's look at another example of a program. Let's see if I remember. Okay. Now here's going to be a slightly, almost the same kind of idea. Was it this one? No. This one actually is what we just did. See, here I have the outer loop affecting the inner loop. Here I have the outer loop variable affecting the inner loop variable. Okay. See there, it affects the inner. So here's the outer loop variable affects the inner loop variable. Okay. So this is just more examples of that. The outer loop variable affecting the inner loop variable. Now let's see. Let's look at, so that was number 3. Here's one. Here's something that's a little bit different. Oh, notice that here I've made things a method. Here this number is how many rows. See, this is the inner loop counter, and then this is how many rows. See, I changed it from row to rows. So this one controls how many rows there are. Okay. And then I made it a method where rows is a parameter to the method, so I could call the nested loop method. The nested loops are actually inside this method. Okay, so I put the nested loops inside of a method here. Okay, I'm going to pull them out of the method and move it to the Java visualizer. Okay. Okay. Now, here, instead of having it a method parameter, I'll just say int rows equal, say, 5. I want 5 rows. Okay. Now, here's what I'm doing here. Instead of having, where is he? Instead of having a for loop with one for loop inside of it, I could actually do the following pattern. Here's the pattern we're going to be doing now. I'm going to put 2 for loops inside. I'm going to say, essentially, pick your row, then do some of the columns, then do some more columns. So I'm going to put 2 for loops inside of a for loop. And essentially what this is going to be is, this is going to be the first half of the columns, or the first part of the columns, and this will be the second part of the columns. And the idea is I want to do something different for the first part of the columns and something else for the other parts of the columns. So this is another little trick we're going to use. So the outer loop will pick a row, but then the 2 inner loops together will go all the way across the row. This will do the first part of the row. This will loop through the first part of the row, and then this will loop through the second part of the row. Okay, so let's look at a picture. Let's see what this thing generates as output. Okay, now see, here's how I get the upper half triangle of a table. See, for each row, I had to separate it into 2 pieces. Leading spaces, that's actually this part of the loop here. This part here gives me leading spaces. So if I look at one of my rows, I have to start with a bunch of spaces, and then I can print out some stuff that's not spaces. So this picks a row. This puts the first part of the row, which is going to be all spaces. And then this finishes the row, and then here's the new line. So I need 2 for loops to go all the way across a row. because I need to change. Now, this could also be done with if statements. Somebody asked earlier if you could have an if statement. I could have an if statement inside of a for loop that said if I'm less than a certain number, print space, and if I'm greater than a certain number, print J. It's hard to say which is an easier way to do it. I could either do it with 2 for loops, or I could do it with 1 for loop and an if statement. Right here, I've done it with 2 for loops. This for loop does the first half of the row. This for loop does the second half of the row. I could have used 1 for loop, but then had an if statement that asked, am I in the first half of the row or am I in the second half of the row? And it's kind of a little bit of a personal choice of which one you might think is better, to have 1 for loop that does the first half and then 1 for loop that does the second half, or just have 1 for loop, but then an if statement that says, am I in the first half or am I in the second half of the row? Okay, so right now I'm doing it with 2 for loops. Okay, so this is now this pattern lets me draw the upper half triangles. So for example, if I just change that from a J to a triangle, to a star, see, there's out of this table here, I'm printing the upper half triangle of it. But to get these blanks here, I have to explicitly I have to have something that puts those blanks in there. Yeah. See, when I did the lower half triangle, I didn't even put the blanks in there. If you go back and do this example here with the lower half triangle, I'm not printing any spaces after that star because I don't need to. Print 1 star, go to the next line. Print 2 stars, go to the next line. I don't need to print space, 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 space after that. I don't need to print space, 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 space after that because I get what I want here. Occasionally, I do need to print space, space, space after that. If I do, then I need another for loop in there. Okay. If I need, like, actually, let me do something over here. Let me make a little change to this one. Let me follow this one with another loop. Now I want to start this one at row +1. Start this one where this one left off and let this one go up to 10 and print a dot. Watch what happens. Notice how I printed a square table and each row was some part stars, then dots. 2 stars, 8 dots. 3 stars, 7 dots. 4 stars, 6 dots. Okay? So see, I needed 2 pieces. A for loop to do the first half of the row and a for loop to do the second half of the row. I started from 1 up to row. That took me up to the middle of the line. Then I went from row +1, one step over, up to the end. Okay, so I picked up right after I left off by this loop. Where this one left off, I picked up on this one, and then I went all the way to the end. Okay, so then I went to the end. Okay, but if I just wanted spaces here, I don't need to print them. So if I chop off this one, okay, now I'm not, now I just get space, now I'm getting spaces for free. See, I get the spaces for free. But when you want the spaces in the front, there's no way to get them for free. There's no way to get those spaces for free. Now, if I change the spaces to a dot, you can see that I'm going to print, whoop, I can't do it here. If I change these spaces to a dot, see, it looks more square now. See, but there's a dot at the beginning, 2 dots at the beginning, 3 dots at the beginning, 4 dots at the beginning. That makes it more obvious that I'm printing a whole table. But a lot of times we just want spaces. So sometimes we just want spaces at the beginning. But if the spaces are at the beginning, we call those leading spaces. You have to put in the leading spaces. If you want the spaces at the end, those are called trailing spaces. You can get them for free if you want. You don't have to put in the trailing spaces. You can kind of just, essentially a blank, putting nothing is just like putting a space, okay? If I go back here, one last example. If I go back here and I put spaces here, I'm actually literally putting in the trailing spaces, but I won't, they're there, but I won't really see them. But I can actually highlight them. See how I can highlight them now? See how I can highlight them? They're actually there, so I can highlight them. When they weren't there, you couldn't highlight, there wasn't anything there to highlight. So now I can do this, and I kind of see, oh, there really are invisible trailing spaces. If I go back to this one, just now watch. It's interesting. There's all kinds of subtle differences. If I highlight this whole thing now, see how it highlights as a triangle? Because there are no real trailing spaces. That's a subtle difference. They look the same, but if you highlight this, it's telling you, well, there really aren't any trailing spaces. On the other one, when I highlighted it, there really were trailing spaces. And so then this would turn blue over here. Real subtle differences. Yeah, and that's what we want to play around with. We're going to play around with nested for loops and play around with all these differences. Do I really want there to be trailing spaces, or do I want free trailing spaces? If I want leading spaces, I've got to put them in there. There's no way to get leading spaces for free. And then I might just want to actually show them. Instead of having spaces there, I can put @, and now it doesn't even, now it really looks, see, now I see everything. I see there's no hidden spaces. Okay, so that's what we're going to be playing with. On Thursday, we'll do more examples of these things, more examples of nested for loops, sometimes with one for loop, sometimes with two for loops. If we have more than one for loop, it's usually this does part of a row and this finishes the row. Do the first part of a row, do the second part of a row. Okay, and so we'll do more examples like this on Thursday. Okay, so going over, I'll go ahead and stop sharing. Again, if you have any questions, send me an email or come to office hours. Please, I'll put all these examples up on the course website so you can see these examples again, and play around with them. You can make little changes in these things, and you can get lots of different pictures. You can get lots of different pictures by making little changes to these, and that's actually what we're going to work on. We're going to work on, I'll show you a picture, then we'll try to write code to draw that picture. That's one of the ways that's kind of problem we'll look at. So I'll give you a picture, and then we write code to duplicate the picture. Okay, so I'll stop sharing, and we'll meet again on Thursday. Okay, bye-bye.